When you're multiplying decimals, the first step is to estimate the answer. So if we had a decimal like this, for example, 2.7 multiplied by 5.1. Okay, let's say that that's the decimals that we're multiplying. 2.7 is close to 3. So in my estimate in my head, I would be going to myself, okay, that's kind of the same as saying 3 multiplied by 5.1 is closest to 5, okay, times 5. So 3 times 5 equals 15. All right, so I'm looking at an answer when I multiply these out properly that's going to be close to 15. If you don't know why I'm rounding 2.7 to 3 for my estimate, then watch this next little clip here and I'll explain to you how I can use a number line to help me do this. But this is also something that you should eventually be able to do in your head with no number line. When we're doing our estimate for 2.7 times 5.1, our first step is to be able to identify the whole numbers on our number line. So 3 is one of the whole numbers and 2 is the other. Now let's see where 2.7 sits on this number line. Right here, there's 2.7. Our next step then is to figure out, is it closest to 3 or is it closest to 2? 2.7 is much closer to 3, so we can quickly round that to 3. The next number we need to find on our number line is 5.1. So I'm going to scroll along the number line until I find 5.1, and then I can identify the whole numbers next to 5.1, which is 5 and 6. 5.1 is closest to 5, therefore back here would be going 3 times 5, which equals 15. And so after rounding each of the decimals to the closest whole number, we can make a reasonable estimate for what our answer should be. Doing an estimate like this is very helpful because it lets us check our answer and make sure we haven't made any ridiculous mistakes. For example, if we end up with an answer that's 143.6, I know that I've made a mistake because that's nowhere near the answer 15. If my answer, for example, comes out at 14.36, that might seem a little bit more reasonable because that number is close to 15. So when we make an estimate, it lets us use our logic to check whether our answer is reasonable or not reasonable. And that's a very important skill to have, especially when you're doing tests and things like that where you're not allowed calculators. If you can do really quick estimates in your head, it really helps you to make sure you haven't made those silly mistakes that we often do when we're under pressure. All right, so now that we've done our estimate, the next thing we're going to do is we're going to multiply this out. So I'm going to write my multiplication without using the decimal points. So it's going to be 27 multiplied by 51 because that's what I would have if I removed these decimal points. So let's go 27 multiplied by 51. Now I've got a 2-digit by 2-digit multiplication here, which means I know I'm going to need 2 lines. And on this line, I'm not going to need a place value holder, but on this line, I will need a place value holder. Some people like to put a 0, other people just like to move in. I always put a 0 because otherwise I forget and I just start my answer here and I always make that mistake. So I always use a 0 and then I know I'm going to have to do some kind of addition here. So I put another line there and I put a plus symbol there. And that's how I set myself up before I start a 2-digit by 2-digit multiplication. So now I'm going to multiply out, just like I would with any other multiplication. So I pretend the 5's not there and I multiply the 1 out. So 1 times 7, 1 times 2. Let's do that. 1 times 7 is 7. 1 times 2 is 2. That was a fairly simple one to do. And now I'm going to ignore the 1 and I'm going to multiply out the 5. So I'm going to go 5 times 7 is 35. 35. See, I nearly went to put my 5 there. It was only that I had the 0 there that I remembered I had to put it there. So now I'm going to go 5 times 2 is 10 plus 3 is 13. So I'm going to just write it down like that, 13. And now the next step is to do my addition. So 7 plus 0 is 7. 2 plus 5 is 7. 3 plus nothing is 3. And 1 plus nothing is 1. So that's my answer, but obviously that's nowhere near 15. Now, if I was going to use my logic, I could simply put my decimal point in where it makes sense. So 1.3 seems a little bit too small because it needs to be close to 15. 13.7 seems pretty logical, so that might be a place where I could put my decimal. What about if I made my answer 137.7? Well, that's way too big because we need to have an answer close to 15. And if I put my decimal point there, then I'd have 1,377, which is really way too large. All right, so that's one way I can do it. I can use my logic and I can use my estimation to help me figure out where my decimal point goes. But we have a much more reliable method to use than that. And our reliable method is to count how many places after the decimal point we have in each of our numbers here. So here I've got a 7, so that's 1. And here I've got a 1, so that's 2. So I've got 2 numbers after the decimal point. So in my answer, I simply give myself 2 numbers after the decimal point, just like I did in my question. So there's 1 there, that makes 2. So I need those 2 numbers here, and then I'm going to put my decimal point there. So I have 1 decimal place, just like I did there, 1, 1. So that's what my answer is going to be. And to double check, I can look at my estimation, and yes, that seems very reasonable. So 13.77 is my answer. Okay, in my second example today, I've got 3.86 multiplied by 4.21. Now remember, my first step is to make an estimate. So I'm going to be estimating 3.86 times 4.21. So 3.86 is very close to 4. So I'm going to go 4 multiplied by 4.21 is also very close to 4. So 4 times 4 equals 16. So my estimate is, my answer is going to be very close to 16. Okay? Right, my next step is to multiply out these 2 numbers. Now remember, when I'm multiplying, I remove the decimal point. So my multiplication will not have the decimal point written. So it will be 386 multiplied by 421. Make sure you've left yourself enough space here in case your answer needs to go out that far. And in fact, I'm going to move my question over just a little bit because I don't think I have left myself enough space. We'll do our equal sign there. So now this time here, that's a terrible equal sign. I'm going to do that again. So because it's a 3-digit by 3-digit number, I know I'm going to need to leave 3 lines here. I'll leave 1 line to multiply out the 1 by all of these numbers. I'll leave another line to multiply out the 2 by all of these numbers. And in this units column, I need to do a place value holder. And then my third line will be when I multiply the 4 out by all of these numbers. So this time I need to put 2 place value holders. So one in the ones column, or the units, and one in the tens column. And then under that, I know I'm going to be doing my addition. So I'm going to put my plus sign here. So if I get it all set up like this from the very beginning, I'm less likely to make mistakes. So my first step now is to multiply the 1 out and write my answer here. So 1 times 6 is 6, 1 times 8 is 8, 1 times 3 is 3. That was fairly simple. Now I'm going to be looking at the 2. I'm ignoring the 4 and the 1, and I'm multiplying the 2 out like it's the only number there. So I'm going 2 times 6 is 12. 2 times 8 is 16, plus 1 is 17. 2 times 3 is 6, plus 1 is 7. I've rubbed out my regrouping from up here before I begin multiplying out the 4 so I don't get confused, because I know that I'm going to need to do some more regrouping with the 4. So this time I'm going to go 4 times 6. 4 6s are 24. Then I'm going to go 4 times 8. 4 8s are 32, plus 2 is 34. And 4 times 3 is 12, plus 3 is 15. Okay, so now I can add these three numbers together to get my final answer. 6 plus 0 plus 0 equals 6. 8 plus 2 is 10, and we just do it like a normal addition using our regrouping. 3 plus 7 is 10, plus 4 is 14, plus 1 is 15. 7 and 4 is 11, plus 1 is 12. 5 and 1 is 6, 1 and nothing is 1. So my answer at the moment is 162,506, which is a pretty big number, right? So once again, I look back up at my estimate and I know that my answer needs to be close to 16. So that to me straight away tells me that that's where my decimal point should go, right there, to make it 16.2506, because if I put my decimal point there, my number would be 1.62506, which is way too small. And if I put my decimal point here, my number would be 162.506, which once again is also way too big, okay? So I know my decimal point's probably going to go there, but I'm going to double check that. And the way I'm going to do that is I'm going to count how many decimal places I've got here and here. So this is 1, this is 2, this is 3, and this is 4. Okay, so I've got 4. So now I need to go to my answer. I need to count 4 numbers. 1, 2, 3, 4. So they're going to be on one side of the decimal place. So 4 numbers on this side, which means my decimal point definitely goes there. So my answer is 16.2506. And that's very close to 16, which means I know I must be pretty close unless I've made an error with my multiplication or addition here.